So what I want to move on to now is this idea of expectation. Now, before, when we were working with data, we didn't actually use the word expectation, okay? By expectation, what I literally mean is what is the value that I expect to get? In other words, if I were to walk in through that door and select somebody at random, how many siblings would I expect that person to have? In other words, which is the one with perhaps the highest probability? Yeah? So what is the value that I expect to get? Now this sounds very similar to stuff that we were looking at before. What does that sound like? So if we were looking at data, what would you call the value that we expect to get? Begins with an M. I heard it. So if I was looking at data, okay, and if I just pulled a value out at random, what would I call the value that I expect to get? So if I gave you a set of data like this, okay, what value would I expect to get? Why? Why? Exactly. It's the measure of central tendency. Are you happy with that? Okay. So the reason why I expect to get the 3 is because it's literally the measure of central tendency. It's the average. Okay. It's the average. Now you remember there were 3 measures of central tendency? Mean, median, and mode. Good. Exactly. So literally, when I say the word expectation at you, just think that's an equivalent for the measure of central tendency. Let's just use the mean in this case. Okay, the mean, right? So by expectation, I'm literally talking about mean. Now the reason why I call it expectation and not mean with a probability distribution, in fact that's a question for you. Why do you think I call it expectation and not mean? So dealing with this probability distribution, why do you think I call it expectation rather than mean? Have a think about what I said right at the very start, okay? I said we now don't know anything about the data which this was collected from. We just have the probabilities associated with them. Now, in order to work out the mean, you need data in front of you, yeah? You literally add them up and divide by the number which you have. Does that make sense? So now you don't have that data, you can't work out the mean, but you can still find a way to find the value you expect to get, okay? So just be aware, if I say the word expectation, think in your head, he really means mean, but I can't call it mean because I don't know anything about this data anymore. Does that make sense?
So expectation is when you don't know the sample?
Exactly. So expectation is when you just have probabilities to work with. Yeah? So probability of an outcome coming up, then you work with expectation. If you actually have data in front of you, then you can find the mean. But we don't have data here, we just have probabilities. Is that clear? Good, fantastic. So, what I want you to do is consider this data here. So this data set has got 3 2s, a 3 and a 4. So we've got 2, 2, 2, 3 and 4, okay? Now, ordinarily, how would I work out the mean of this data? Because this is data now, so I can work out the mean. How would I work out the mean of this data? Good. Divided by 5. Perfect. That's how I'd work out the mean of this data. Okay? Now what I'm actually going to do here is kind of manipulate this a little bit because I want to make this look more like a probability. In other words, what's the probability of a 2 coming up? What's the probability of a 3 coming up? What's the probability of a 4 coming up? Okay? So let's have a look at this. Would you be happy that I could rewrite this as this? Yeah? Seems reasonable, right? Would you also be happy I could rewrite this like this? Yeah? So in other words, I've literally just rewritten this according to the number of times that each variable occurs. Okay? So for example, 2 comes up 3 times. There's 3 2s. 3 comes up once, so 1 time. 4 comes up once. Yeah? So I'm literally just rewriting this idea of mean in terms of how many times each thing comes up. Okay. Would you also be happy I could rewrite it like this? Yeah, seems reasonable. Now the reason why I wanted to rewrite it like this, because have a look at what these numbers actually mean. So we've got 3/5, 1/5, and 1/5. If I was going to convert this frequency, or if I was going to convert this data into a probability distribution, so in other words, let's say x is the outcome, okay, and the probability that x equals x is on the denominator, are you happy I have 3 outcomes? I have 2, 3, and 4. What's the probability of picking a 2 from this data?
1, 3 or 5.
What's the probability of picking a 3?
1 over 5.
Probability of picking a 4?
1 over 5.
Now have a look. Have a look at this. Have a look at this. Okay? In order to work out the mean of this data, I've literally just worked through the mean and just manipulated a little bit. This thing down here, these things which I've drawn a black box around, literally represent the probability that each number is going to come up. And I'm multiplying it by each individual outcome. So a 2, a 3, and a 4. Okay? So in order to work out the expectation following this idea here, what I need to do is I need to take each outcome, which remember is just x, okay? And I need to multiply it by its associated probability. So for example, I took a 2 and I multiplied by its associated probability. Do you see that? So I need to multiply by its associated probability, which I'm just going to call P, okay, P. And then I need to add all those things together. So I need to add them all together. You happy with that? Okay. So the expectation, which really just means mean, okay, is literally just achieved by taking each outcome, multiplying it by its associated probability, and then adding it all together. Okay. Now I need to give a bit of definition to the expectation. Well, it's an expectation, so I'm going to call it an E, and it's going to be E of my random variable. So the expectation of the number of siblings, the expectation of x. Is that okay? So expectation of x is given by this. Because it is associated with mean, I could give it that symbol there as well, because it is a mean of sorts. Okay? So there's 2 symbols I can use, either mu for mean, or the expectation of x. So either mu or expectation of x, but this is how you work it out. Okay? So can you then work out the expectation of this thing up here for me? So what is the expected number of siblings that somebody will have? How many siblings do we expect somebody to have? What's E of x from this probability distribution? So you're happy this is how you calculate it? Yeah? So you literally just go through, and you take each outcome, which is 0 in this first case, and multiply by its associated probability. So 0 times 53%. And then you do 1 times 27%, and then 2 times 7%, and then 3 times 7%, and then 4 times 0%, 5 times 7%, etc., etc., etc. You just end up adding all of those things together. That's literally what this means. Is that okay? Good. Did we get an answer? Did we get a number? Has anybody done it? You reckon? 0.92? Okay. Seems reasonable. 0.92. Now, by the way, what type of random variable are we dealing with here? Discrete or continuous? So it's number of siblings. So it's discrete, right? But have a look. The expectation, in other words, the number of siblings which we expect somebody to have if we pull them out at random is 0.92. Yeah? Now, this does have some meaning, but don't think about it in terms of whether it's discrete or continuous, okay? So for most of the time, when you're dealing with discrete random variables, fully expect your expectation to come out as a non-discrete number, so a number which you're not necessarily expecting, yeah? So in this case, it comes out as 0.92. Clearly, somebody can't have 0.92 siblings, okay? But you can still interpret that as it's going to be a value close to 1. It's going to be a value close to 1. Is that okay? Yeah? So even though that the variable, the random variable, is discrete, the expectation is not necessarily going to follow a nice round whole number.
Even if it was 1.
Oh, if it was 1, great, perfect.
Means
Yeah.
like, what does represent the 1 expectation?
So all this represents is if you walked in through that door, if somebody walks in through that door, shut their eyes, pulled somebody out at random, you would expect that person to have 0.92 siblings. Clearly that doesn't make sense. If it was 2 siblings, that would make more sense, okay? But what I'm just trying to say is don't get surprised if this number doesn't come out as a nice whole number. Is that okay? Okay, good.